Alexander Baina here and welcome to Chalk Talk. In this episode, we are going to talk about electromagnetic radiation, a way of viewing the universe. Everything in the universe emits a type of energy in the form of waves. You, me, the dogs, the trees, the cloud, the planet, the stars, everything. This is how scientists study the universe by detecting and observing these energies or waves. A wave that is propagating in an electromagnetic field is called an electromagnetic radiation. The electromagnetic wave properties are the following: speed, wavelength, and frequency. The speed. All electromagnetic radiation travels at the same speed, which is the speed of light. This is about 3 times 10 raised to the power of 8 meters per second. Wavelength. This is the distance between identical points, such as two adjacent crests, propagated in space. Finally, frequency. This is the number of waves that pass a fixed point in a given amount of time. The 7 electromagnetic waves are radio waves, microwaves, infrared, visible light, ultraviolet rays, X-rays, and gamma rays. Planets like Jupiter emit a kind of wave due to charged particles, and these are accelerated through the field and give off radio emissions called radio wave. A wave size of 30 centimeters with a frequency from 1 GHz to 300 GHz. This is relatively shorter than a radio wave. It can burn body tissues when exposed. This wave is called a microwave. Microwaves are used in point-to-point communication links, wireless networks, radar, satellite, and spacecraft communications. Microwaves are also used in cancer treatment, remote sensing, and cooking. A type of wave that is generated by warm and hot bodies. Sometimes this wave can be felt by humans, such as the heat from the sun. This type of wave is utilized in electric heating, cooking, remote controls, short-range communications, optical fibers, and thermal imaging. Although we cannot feel them most of the time, this type of wave can damage our eyes and skin. This type of wave is called an infrared wave. A wave propagation ranging from 380 to 700 nanometers in length. This wave is also used in medical applications such as laser surgery. Waves that make our laptops, computers, cell phones, and TVs to work. A type of wave that human eyes can detect. This wave is called light. This next wave can be detected by insects such as bees. It is produced by the atomic excitation from a star like the Sun. 99% of this wave can reach our planet. On Earth, this wave can be produced from light bulbs, crackling of fire, and man-made technologies. Overexposure to this wave can cause blindness and cancer. However, this type of radiation helps in hardening of dental fillings, detecting fake pills, and sometimes used in nightclubs. This wave is called ultraviolet rays. When an atom's electron changes its energy level, let's say from high to low, it emits an energy called a photon. This excess of energy is released as waves, which travel in straight line at the speed of light, which cannot be bent. This type of wave is utilized in hospitals, like detecting bone fractures. This is also used as a security measure in airports, seaports. But long-term exposure to this kind of wave can also cause cancer. This type of wave is called an X-ray. We are now down to the last type of wave. So this is the smallest ray among all the electromagnetic spectrum. This is produced by the hottest and the most energetic objects like the neutron stars, pulsars, supernova explosions, and regions around a black hole. On Earth, these rays are produced in nuclear explosions, lightning, and radioactive decay. At higher amounts, this ray can vaporize a person to death. However, it is used in hospitals to cure cancer. This type of ray is called the gamma ray. The arrangements of the distribution of the different electromagnetic radiation is called an electromagnetic spectrum. As mentioned earlier, scientists were utilizing all these waves to study the universe. This time, we are going to talk about the different detectors and different imaging devices that are used to detect all these waves in studying our universe. Radio waves from space can be collected and focused on parabolic dishes called radio telescope. The world's most powerful radio telescope can be seen in New Mexico. They are called the Large Array Radio Telescope. Space microwaves, such as the one in the photo, are detected using a scatterometer radar. This is how the universe looks like in an infrared imaging device. Infrared rays are detected using an infrared detectors and infrared cameras. Visible light is collected and magnified by a telescope. We have the 4 different types of telescopes that are presented in here: the Refractor Telescope, Refractor Telescope, Dobsonian Telescope, and the Cassegrain Telescope. A refractor telescope, also known as refracting telescope, uses a lens as its objective to form an image. A reflector telescope, also known as reflecting telescope, uses a single or combination of curved mirrors that reflect light and form an image. The refractor telescope is better for observing the planets and the moon, while the reflector telescope is best for deep sky observation, but this can be very expensive. The Dobsonian telescope is a mount-type telescope that is very similar to the Newtonian telescope. This is due to the way the eyepiece is mounted. It is great for light gathering and ability to see clearly faint objects. The Cassegrain telescope is better for objects that require very high magnification, such as planets, the moon, double stars, globular clusters, and planetary nebulae. A device with primary mirrors coated with special materials are used to detect an ultraviolet radiation that are used in space. This is what we call an ultraviolet telescope. X-rays are detected from outside the Earth's atmosphere using an X-ray telescope. Gamma rays are detected by a detector installed in a satellite orbiting our space, and this is called the Fermi telescope.